Okay, now we have reached the second part of our simple harmonic motion. If you look at this spring mass system, look carefully. When is the mass stop? When it stop? Yeah, it stopped at the amplitude because the amplitude is the turning point. It stopped temporarily. Yeah, it stopped temporarily at the amplitude, at the top and at the bottom. Yeah, when they change direction. Yeah, here change direction and here also change direction. So the top and bottom, the velocity is equal to 0. So the kinetic energy is 0 at the amplitude. But for the elastic potential energy, it is the maximum at the amplitude because here is maximum compression and at the below it is maximum extension. Okay. Now, when does the velocity highest? Velocity is highest at the equilibrium. At equilibrium, the mass move fastest. Yeah, the velocity is highest at the equilibrium. It has highest kinetic energy. The mass has highest kinetic energy at the equilibrium. The kinetic energy is maximum at the equilibrium, but kinetic energy is 0 at the amplitude. But elastic potential energy is maximum at the amplitude because maximum compression and maximum extension. But elastic potential energy of the spring is 0 at the equilibrium. Okay, because at the equilibrium, no extension, no compression. Okay. All right. Now let's look at the my notes. So I just revert this spring mass system become a horizontal oscillation. Okay, horizontal. Actually, vertical and horizontal is the same. Okay, same. So the center is the equilibrium, and at both ends, it is the amplitude. Okay, amplitude. So okay, at the center is equilibrium, x equal to 0. Okay, x equal to 0. Now, if the block goes to the right, the spring will expand. The spring will become longer. Extend the spring. When you extend the string, the displacement is positive. Displacement is positive because you extend the string. Displacement is positive. So at this end, it has maximum displacement. We call it amplitude. But if you go to the left, compress the spring. When the spring is compressed, displacement is negative. So remember, positive displacement if the spring expand. If the spring expand or become longer, the spring become longer. Negative displacement if your spring is compressed. Okay, this is how we see the positive and negative. Positive displacement means the spring expand. Negative displacement means the spring compressed. Okay, so here it go expand the spring, displacement is positive. Okay, but you compress the spring, displacement is negative. Good. Now, velocity is 0. Velocity is 0 at the amplitude. Because why? Here is stop temporarily at the amplitude. Change direction. But velocity is maximum at the center. Maximum at the center. Yeah. So, yes. Vmax, maximum velocity, is actually... Okay, let us start with the maximum displacement. Maximum displacement is amplitude. Maybe we just look at back the formula. You see that? You see this formula. Maximum displacement is amplitude. Maximum velocity is a omega. Maximum acceleration is a omega square. Do you see that? Maximum displacement is amplitude. Maximum velocity is a omega. Maximum acceleration is a omega square. Now, look. So, maximum velocity at the equilibrium. Okay? Maximum velocity at equilibrium. This, when object at over here, maybe this object is going to the right or going to the left. So, velocity can be positive, negative. Okay? So, that's why I put positive, negative a omega. Right. And then, look. Acceleration. Acceleration is 0 at the equilibrium. Still remember what the equation of the simple harmonic motion equation, which is a equal to negative omega square x. So first thing you know, a is proportional to x. Second thing you know, a opposite x, isn't it? First thing you look, the higher displacement, the higher the acceleration. So you look here. But when displacement is 0, acceleration is 0, isn't it? Because a is proportional to x. A is proportional to x. When x 0, a is 0. When x maximum, a also maximum. So maximum displacement at the amplitude. So maximum acceleration also at amplitude, because they are proportional. However, acceleration is opposite the displacement, opposite direction. So when you see displacement is positive, acceleration is negative. Acceleration is negative. Why acceleration negative? Because when you extend, the spring want to pull back. The spring want to pull back. So there is a force to the left. The restoring force. Restoring force pulling back to the left. So that's why acceleration is to the left. It's negative. So when displacement positive, acceleration is negative. Acceleration and displacement always opposite direction. But when displacement is negative, acceleration become positive. Acceleration become to the right. Why? Because now you compress the spring. When you compress the spring want to push you back to the equilibrium. Want to push you back to the equilibrium. The spring push the block to the right. That's why acceleration to the right. Acceleration is positive. So displacement negative, acceleration positive. It's like when the block go to the right, you extend the string. You extend the spring, so the spring want to restore back, want to pull back. But when you compress the spring, the compress push back, push outward. You see that? So that's why this object keep on oscillating left and right, non-stop. Because the spring try to restore this object back to the equilibrium position. When you extend, you want to pull. When you extend, that means when the displacement is positive, you extend the spring. Acceleration is negative. Acceleration negative means the spring want to pull back. When you compress a spring means displacement negative. The spring want to push back out. So acceleration is positive to the right. Okay, that's why acceleration always opposite the x. Okay, good. Now look at here. Velocity is maximum at the center. Okay, the block is fastest at the center. So kinetic energy also maximum at the center. Just now, in the first video, I did say that when maximum kinetic energy is equal to the total energy, maximum kinetic energy is the total energy, which is also half m omega square a square. So at the equilibrium position, the maximum kinetic energy is equal to the total energy. The maximum kinetic energy here is actually half m omega square a square. Okay, so kinetic energy is maximum at the equilibrium, but 0 at the amplitude because velocity is 0. So kinetic energy is 0. Stop for a while. But for potential energy, it's the opposite. Potential energy is 0 at the center, at the equilibrium. Why? Because at the equilibrium, the spring. When we talk about, one thing I want to get straight, when talk about kinetic energy, we refer to the block. When talk about elastic potential energy, we talk about the spring. Okay? Understand that? So, for the spring at the equilibrium, it has no extension, no compression. So potential energy is 0. Okay? But at the amplitude, at the negative amplitude, maximum compression, maximum compression, when you compress a spring, it stores elastic potential energy. So at the maximum compression, it has the maximum elastic potential energy stored in the spring, which is also equal to the total energy. So the maximum potential energy there is half m omega square a square. Yes, so at this point, the U max here is half m omega square a square. Okay? Now, at the maximum, at the other end, the maximum extension, that means the spring is extend to the maximum. So the spring also stored maximum elastic potential energy. Maximum elastic potential energy, which is also equal to the total energy, half m omega square a square. Okay? So this is the very important diagram. I hope you remember this. Okay. Okay. So let us move on to the third part. See you in the third videos.